Hello everyone, and welcome to the implementation of a stack lecture. In this lecture we're going to be implementing our own stack class. As always, there's a Jupyter notebook with notes and the full code for you to check out, as well as some examples of using our own stack class. So before we begin on implementing this, what we want to do is just do a quick review of the properties and methods of a stack that we're going to be implementing. So just a reminder from the last lecture, the stack data type is defined by being structured in a way that their last in elements are also the first ones out. So it's an ordered collection of items where items are added to and removed from the end called the top. So what we're going to do is create our stack class with the following operations. First one is just going to be stack, which creates a new stack that is empty. It's not going to need any parameters, and it's just going to return an empty stack. The next one is going to be push. That's going to add a new item to the top of the stack. It needs the item and then just returns nothing. Pop is going to remove the top item from the stack. It doesn't need any parameters and it will just return the item. The stack is then modified. Peek returns the top item from the stack but doesn't actually remove it. It doesn't need any parameters, and note the stack isn't modified. So it'll show you the top item but it won't remove it. IsEmpty is going to test to see whether the stack is empty. It won't need any parameters and will return a Boolean value, either true or false, depending if it's empty or not. And then finally, size will return the number of items on the stack. It won't need any parameters and it's just going to return an integer depending on the size of the stack. So let's go ahead and jump over to a Jupyter notebook and start implementing this. Let's go ahead and zoom in a bit so you can get a better view. Okay. First thing we're going to do is create our class. Let's go ahead and make a stack object. Okay. Let's go ahead and start off by just calling self. And we'll say self.items is equal to an empty list. So we're going to be using the list as kind of a base off of the stack. So self.items, we have an empty list. So there's no items in the list yet. So when we call stack, we're just creating an empty stack. We'll go ahead and make our isEmpty method. Just takes in self, no other parameters. And it's going to return the Boolean self.items equal to empty list. So you notice here we're just returning the Boolean is the items, which when it starts off as just an empty list, is equal to an empty list. If we push more items into the stack, this will not be true and isEmpty will return false. Okay. Next, let's go ahead and describe how we're going to push items. So I'm going to say self and then take in an item, and that's just going to be self.items, that list, and I'm going to append to that list. I'm going to append that item to that list. Next, I want to see if I can pop items from the list. In that case, we actually don't need any parameters. We're just going to take the last one in is the first one out. So we're going to just use the list built-in method of popping. So self.items.pop. You'll notice that a list behaves very much like a stack in general. And then let's go ahead and create peek, which is going to be the top item, but we're actually not going to pop it out. We're just going to return what it is without affecting the actual stack. So in order to do that, I'm going to go ahead and use some slicing. So I have my self.items, which is that list of all the items in the stack. And then I'm going to say from length of self.items -1. Return that. So that's going to return that top item, the last one that was put in. Go ahead and check out the slicing for yourself and this indexing to make sure it makes sense to you. But basically it's just the length -1 because indexing starts at 0. Okay. And then lastly, we're going to make a size method, and that's just going to return the length of self.items. Okay, so that's it. Let's go ahead and try it out. I'm going to create a stack called S. Let's zoom in one more time here so we can really see what's going on. And let's go ahead and print S is empty and confirm that that's true. So it is true. Note how I have the closed parentheses since I'm actually calling the method and not passing any parameters. So it is empty right now. Let's go ahead and push an item to the top of it. So now we have push, and let's go ahead and push another item. In this case, we'll do a string 2. And let's take a peek at our stack. Notice it shows us 2. Let's go ahead and push in another item. We'll push in a boolean this time, true. And how about we check the size of our stack? So we should have 3 items, which makes sense. The integer 1, the string 2, and then that boolean true. So let's check if it's empty now. It shouldn't be, but let's make sure our function or our method is working. Is empty? False. So it looks like that's working well. Let's go ahead and pop out all the items and see if we can empty out this stack. So I'm going to pop out item, so that's going to be that boolean we put in. If we pop in another one, think for a second what it should be. It should be that string. There it is. And then finally, we should pop out that integer. So let's go check if it's empty now. And it is empty. Okay, great. So we took a big advantage of the similarities between a list in Python and its built-in properties and how it relates to a stack. So just keep that in mind. But this is a pretty basic implementation of a stack. Best thing to know about this is that last in, first out principle that stacks have. Okay, with that being said, go ahead and follow along with the code either here or in the example notebook. Make sure you understand how to implement a stack, and that's it. Thanks everyone, and I'll see you at the next lecture.